Hello everyone. In this video, we're going to be solving a differential equation. A really cool differential equation actually. So we have y prime equals 2xy divided by x squared plus y squared. So is this a homogeneous equation? Please let me know what you think. And homogeneous equations are actually kind of special, and we can use some special methods. Anyways, for this equation, I can replace y with something, and that is called substitution. What is that thing? I'm going to use y equals tx. Now you might be questioning, like, why is y a multiple of x? Or is y over x a constant? No, I'm not saying that. I'm just changing the variable. T is another variable, and t is actually a function of x. So I'm just claiming that y can be written as x times a function of x, which gives us a function of x, and that's what it is, right? Okay, cool. But not just for that reason, of course. Nice things are going to happen when I do this. Okay, cool. Notice, first of all, that x times y is quadratic, and x squared and y squared are also quadratic. So when we replace y with tx, something is going to cancel out. That's the goal, okay? But before that, before the replacement, let's go ahead and differentiate both sides, because I do need to know what t prime is. T is a function of x, but what is t prime? So let's differentiate both sides. Y prime, the derivative of t, which is t prime. I don't know what t is. It's not like x, where the derivative is 1, because t is a function like u, right? It's like u. T prime multiplied by x plus the derivative of x, which is 1 times t. Great. You can also write this as xt prime plus t. Just looks a little nicer. Now, that's y prime. I'm going to use that here, obviously. What about the right-hand side? So on the left, I have xt prime plus t. On the right-hand side, I have 2xy, 2x tx, because remember, y is tx, divided by x squared plus y squared, but that is t squared x squared. Remember, I told you that something was going to cancel out, and that happens to be 2tx squared over, if you take out an x squared, you're going to get 1 plus t squared, and x squared is going to cancel out. A lot of squares. Okay, nice. And why is this nice? Because we only have x and t in the equation, and that's kind of, you know, a nice equation for many reasons. So let's go ahead and subtract t from both sides to make it even nicer, because my goal is to basically isolate t prime, because I'm going to turn this into a separable differential equation. All right, and we're going to do some fun stuff. Okay, ready? So now let's go ahead and make a common denominator on the right hand side. That's going to give me 2t minus 2t, or not 2t. Okay, sorry, I gotta make that joke. So that's going to give me t, and then minus t cubed. It's just going to be minus t cubed, and then divided by the denominator, which is 1 plus t squared. Awesome. Now what am I going to do at this point? I'm going to write this as a separable differential equation. So let me replace t prime with dt over dx. Okay, and then right hand side just stays the same. It's just a function of t for now, right? And t is a function of x. Anyways, so let's go ahead and do this. Separate the variables. I'm going to put this t thing on the left hand side. So I got to multiply both sides by the reciprocal, and then I want to divide by x and multiply by dx. So I hope this makes sense. I'm going to put everything t on the left, everything x on the right. Okay, ready? 1 plus t squared over t minus t cubed times dt equals dx over x. Awesome, because x has to be divided, right? Not x dx, it's dx over x. So we have to, what do? We have to what? We have to integrate both sides. Well, we don't have to, but if you want to find the answer, you need to integrate. So let's go ahead and integrate both sides. What are we getting, right? So we need to, right-hand side is easy, right? It's just ln. But what about the left-hand side? That's like a complicated, what is it called? Rational expression. So here's what I'm going to do. That's the fun part. We're going to do partial fractions. If you use Wolfram Alpha and say partial fraction decomposition, blah, 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 it's going to do it for you. That's what I did. Do you think I really seriously did this? No. I was just being lazy, because I'm most of the time being lazy. Anyways, so 1 plus t squared divided by t minus t cubed can be written as follows. So first of all, I need to factor this. Can I write it as t times 1 minus t squared? That gives me difference of 2 squares. That's awesome. And then let me write it as 1 plus t squared divided by t times 1 plus t times 1 minus t. Awesome. Now this is really good because I have 3 factors. They are all linear, nice, and clean. So here's what we're going to do. We're going to take this expression and do the partial fractions. Partial fraction basically means, like, imagine you're adding rational expressions. You make a common denominator, and then you make new numerators, and then you combine the numerators, so on and so forth, right? We got to reverse that process. Where does this come from? So it's got to be a sum of 3 fractions. Why 3? Because we have 3 different factors in the denominator. Make sense? So I'm going to write it in this form. A over t, a is a constant, b is a constant, and c is a constant. And this can be done, okay? Partial fractions are very helpful, very cool, very nice method. And then from here, again, without further ado, I'm going to give you what the values of a and b. So this video is not like 25 minutes long. A is 1, b is -1. In another video, we can talk about how to do this in detail. By the way, speaking of another video, I have 2 more channels that I'm going to be announcing. Just wait for the announcement, okay? No content yet, that's why I want to wait a little bit, but I'm excited. Anyways, so once we've found the ABC values, we can go ahead and do the following. 1 plus t squared over t minus t cubed can be written as 1 over t minus 1 over t plus 1 minus 1 over t minus 1. What I did was I reversed this because c was -1, so I can write it in a more convenient way. Make sense? Now here's what I'm going to do. I'm going to attach a dt to both sides, right? And then integrate. So let's go ahead and add dt here and dt here. Put this whole thing in parentheses because that's kind of like a quantity, entity, whatever, tt. And then all we have to do is basically integrate this, and that's easy. What do you have on the other side though? We did have, remember, dx over x on the right hand side. So this is the left hand side, this is the right hand side. I know it's not the right side the way to put it, but hopefully you get this idea. So I'm going to go ahead and integrate this expression right here. You see that? And when I integrate, we're going to forget about the absolute value. I just don't like it. ln t, suppose these are all positive quantities, minus ln t plus 1 minus ln t minus 1. And this, if you integrate that, you're going to get ln x plus a constant c. Awesome. Are we done? Not yet. We've got to put it all together. Using the properties of logarithms, you can basically divide t by the product of these 2 things, because if you take a look at it, it's what it is. You get that equals ln x plus c, and c can be kind of combined, kind of, what is it called? Kind of merged into it as kx. Because notice that this is ln k plus ln x. So here I assume that c is ln k. Makes sense? Because they're constants, so it doesn't matter. Look at this. We have ln on both sides, so we can kind of un-ln or e to the power both sides, and that's going to give us the answer. Make sense? So t over t squared minus 1 equals ln kx. No constant because we already burnt it in. And now, what am I going to do with this? Well, sorry, I wasn't supposed to write an ln. I got too excited. Okay, 2 ln e. So that's a kx. And now, what is t though, right? What is t? Okay, let's find out. But first, I want to do the following. I want to solve for t. Okay, definitely. So let's go ahead and cross multiply. Kx t squared minus kx. And let's put everything on the same side. And guess what? This becomes quadratic in t. Isn't that awesome? Like, there are too many variables, but only t matters. This is quadratic in t. And now we can solve it using the quadratic formula, because quadratic formula is awesome. And that gives us t equals 1 plus minus the square root of b squared, which is 1, minus 4ac. But that becomes a plus sign with a double negative. And this is what we get. Make sense? But what is t, right? You got to back substitute. What is t? T is y over x. Look at that. Of course, they shouldn't be 0, right? In that case, whatever, some requirements. And just replace t with y over x. We have x's on both sides, so we can kind of like just annihilate them. And y from here becomes 1 plus minus the square root of 1 plus 4k squared x squared divided by 2k. If you want to write 2k as another constant, doesn't matter, no big deal. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and hasta la vista.